In this video, I will demonstrate how we can leverage TCE and BYOH together to provision Kubernetes cluster on Linux-based hosts. The video includes 4 parts. First, we will demonstrate how to install TCE. Later, we will demonstrate how to install BYOH provider on the main cluster created by TCE. And third, we will demonstrate how we can create a BYOH workload cluster. And last, we will showcase how we can scale the cluster to heterogeneous hosts, which include x86 and ARM64 based hosts in a single cluster. For those who are not familiar with TCE and BYOH, you can check the follow links. You can always download the latest Tanzu CLI build from GitHub. Before you execute the install script, you need to prepare a non-root user account, and that account should be able to access the Docker service. I encountered some errors from the beginning because I don't have that account ready. And after install the Tanzu CLI, we need to create a key pair, which will be used later by the Mgmt cluster. To create a Mgmt cluster, we can run the Tanzu Mgmt cluster create --ui command to start a web-based installer service. Since the Bootstrap machine is a remote VM, I need to bound the service with a public IP address so that I can access the portal from my laptop. Next, we open the browser and enter the Bootstrap machine IP address. We already have a vCenter set up, and we'll use this vCenter to create the Mgmt cluster. Following the guide, we input the vCenter IP address, username, and password. In the public key section, we paste the public key we created in the previous step. In the Management Clusters Settings section, we choose the control plane and workload instance size as small, provide the cluster name and the control plane endpoint address, which is a static IP address, and click Next. Since we don't use the NSX here, so we can skip this step. We can also skip the metadata section. On the resource section, we choose the VM folder, data store, and the resource pool for the cluster. In the network section, we provide the network name, class service, and port CIDR. We skip the Identify Management section. Then we select the OS image and skip the TMC registration section. We can review the configuration. When everything is alright, we click the Deploy Management Cluster button to start the deployment process. It will take a while for the management cluster to be created. We run Tanzu management cluster get command to list the management cluster status. When this video was created, TCE still used Cluster API v1 Alpha 3, so we need to upgrade Cluster API to v1 Beta 1 for BYOH provider. we download the class control command from GitHub and put it in the OS path. Then we run the class control upgrade command to upgrade the cluster API. Following the BYOH provider getting started page. Since we already have a management cluster created by TCE, so we just need to create a class control.yaml file under the .cluster-API folder. Copy the field content from the page. And we run the class control config repository command. We can find the BYOH provider is listed there. We run the class control init --infrastructure BYOH to install the BYOH provider. Now we can see BYOH provider installed on the management cluster. Now we demonstrate how to create a BYOH cluster. With Tanzu cluster list command, we can see now we don't have any workload cluster in TCE. We run kubectl get BYOH, and now we don't have any BYOH registered in the management cluster. Following the getting started guide, we need to run the BYOH agent on the BYOH host. We have prepared two nodes, so we try to start the agent on the first node, and we can check the agent log. Now we can see we have one BYOH node ready for use, and we run the start agent command on the second node. And we can see that we have two BYOH nodes ready. Next step, we'll use the class control command to create a workload cluster template. I already copied the template to the Bootstrap machine. So you can see we only have two nodes, so the control plane number is 1 and the replica for the work node is also 1. We apply the template. And we watch the cluster creating status by watch the machine status. We can check the agent log. We can see that the first node is trying to bootstrap current node. Now the first node is have been successfully booted. It is the control plane node. The second node, which is the work node, is also start to provision. And we come back to the Bootstrap machine and run the command. We can see that the control plane and the work node is not in ready status. That's expected because we don't apply the CNI as on. So we come back to the first node and copy the Kubernetes config file and we then run the control get node. After that, we apply the Calico CNI plugin. We can see that it's just waiting for the CoreDNS and the Calico port to start up. It will take a few minutes for the pod to start up and running. Now we can see both the nodes are in ready status. And we can find that our first BYOH cluster is up and running there. Next, we will try to register a Pi4 node to the management cluster. This Pi4 node has 8 GB memory. And the same as the other node, we need to start the BYOH agent on the Pi4 node. We can also check the log. Now we come back to the bootstrap machine. We can find that the Pi4 node has been successfully registered there. We then try to update the cluster template. We increase the replica from 1 to 2. And we apply the change. Then we watch the machine creating status. We then come back to the control plane node, which is the first BYOH node, and we run the control get node. We find the Pi4 node is not ready. That's because it's just waiting for the Calico node to be ready. After a few minutes, we run the control get node again. We can see the Pi4 node is ready. And now we have a running BYOH cluster, which includes one control plane node, two work nodes, and one of the work nodes is a Pi4 host.